Hello guys, welcome back to another video of science. Today we'll be looking at waves part 2. So in this video we'll be covering sound waves, ultrasound, seismic waves, EM waves, refraction, producing EM waves and the uses of EM waves. Sound waves. Sound waves are longitudinal waves. Sounds are made when things vibrate. The vibrations are passed on particles and solids, liquids and gases. Sound needs a substance to pass on the vibration, so it can travel through solids, liquids and gases, but not a vacuum. Unlike EM waves, which we'll be talking about soon, which can travel through a vacuum at the speed of light. So on the right we can see a tuning fork, and this is just a representation of how sound waves are created. So we can see compressions, rarefactions. So compressions are where the waves are compressed. Rarefactions are where there's space between the waves. Then amplitude is the maximum displacement between wave from its middle line. The wavelength is the length of one wave. The speed of sound is faster through solids than liquids and slowest through gases. It's because the particles are very close together in solids, so energy is more likely to be passed. Our ears detect sound by converting vibrations in the air, sound waves, into mechanical vibrations in a solid. So the human hearing range is between 20 hertz and 20,000 hertz, and anything above that is ultrasound, which we'll be covering as well. The compressions and rarefactions in the air set the eardrum in motion. As the eardrum vibrates backwards and forwards, small bones are made to vibrate. Ultrasound. Advantages of ultrasound: safe, doesn't cause any harm. The ultrasound waves that have frequency greater than 20,000 hertz. It's too high pitched for human hearing, but many animals such as dogs, cats, bats can hear ultrasound. Dolphins can hear quite high sounds as well. Humans use ultrasound machinery for many things. One of the most well known is to check the condition of newborn babies, where very high frequency ultrasound is used by doctors to explore a baby inside mother's belly. So the ultrasound is directed towards an organ in a narrow beam like a light ray. To find the depth, the ultrasound waves reflect off the fetus and the computer sensor detects the echoes and can build a picture from it. Sonar. Sound travels at 1,500 meters in seawater. Ships send a pulse of sound and time how long it takes for the echo to return. To find the depth, they use a speed equation. Distance equals speed times time, but they need to divide the time they measured in half because sound went to the bottom and back, so it took twice as long. So here on the right, we can see an image of like a boat and how they calculate how far the seabed is. So the pink are the transmitter and the transducer, the waves that come back to the wave. EM waves are transverse waves that transfer energy from the source of the wave. There are 7 different EM waves, and the wavelength these vary from 10 to minus 12 meters to 1 kilometer. And the shortest wavelength and highest frequency is gamma rays, and the longest is the radio waves. So visible light is the light that we can see. Things that all waves have in common: they're transverse, they obey energy from one place to another, they obey the wave equations which we learned in the previous episode. V equals F times lambda. They can travel through a vacuum, unlike sound waves, travel in space at a speed of 300 million meters per second, so that's almost the speed of light. Uses of different EM waves. The visible light, optical fibers carry information, e.g. internet, which is really important in computing, which is what I learned in computing. And fiber optics are replacing copper cables nowadays. Other uses are photography and photocopying. Infrared rays, so all objects emit infrared, so it's heat. So the hotter the object, the more infrared it emits. IR waves, heat object. The uses of them are heaters, IR scanners, and IR cameras. X-rays and gamma rays. X-rays are used in hospitals. So we know people in hospitals they take X-ray of bones to see if there are any broken bones, and then gamma rays are used to sterilize equipment. But both of them are really dangerous in high volume and cause cancer and death. So microwaves are used in communication. They can even pass through atmosphere for satellite communication in space. They're used in cooking, like the microwave ovens, which we use to heat food. Radio waves have the longest frequency and are mainly used in communication and TV signals, TV mobile phone signals. Highest frequency radio waves carry more information but have a shorter range. So if it's a low frequency, that means it has a long range, but if it's a high frequency, it has a shorter range. Then fluorescent substances are used in energy efficient lamps. They absorb ultraviolet light, so this is what it's about. So ultraviolet light harm the skin because it causes skin cancer and tan, and it's also used in banknote security. So if a robber goes into a bank, there's special ink that falls on him, and then they can find the criminal by that ink, and they also use to disinfect water. So now we'll be looking at refraction. When a light ray travels from one medium to the other at an angle, it will change direction. So on the top, we can see that the incident ray and the refracted ray is similar terminology to reflection, which we looked at in the previous PowerPoint. If the light ray is entering a more dense material, it will bend towards the normal, and then the angle of incidence will be bigger than the angle of reflection, which is a bit different from reflection, where angle of incidence is equal to the angle of uh, refraction, but in the refraction it can change. If the light ray is entering a less dense material, it will bend away from the normal. The angle of incidence will be smaller than the angle of refraction. Thank you for watching. Please like, subscribe, and look out for Waves 3.